This is R.d.sharma Solutions Class 12 Chapter 19. Exercise 19.25 we are taking from Indefinite Integrals. Now this question is exactly similar to the previous question we have just done. So this question is equivalent to x tan square x. So if we resolve this question, it will finally comes down to x tan square x only. Now we have sec 2x minus 1 and sec 2x plus 1 as numerator and denominator. The sec can be written as 1 by cos, so 1 by cos 2x minus 1 divided by 1 by cos 2x, this is plus 1. Now just take the LCM, you will find 1 minus cos 2x divided by cos 2x in the numerator. So let me write it, 1 minus cos 2x divided by cos 2x. Similarly, 1 plus cos 2x divided by cos 2x in the denominator. Now this cos 2x can be cancelled out, so we are having 1 minus cos 2x and 1 plus cos 2x. And from our trigonometric knowledge, we know that there is a straightforward formula of this 1 minus cos 2x and 1 plus cos 2x with cos and sine. So 1 minus cos 2x is 2 sine square 2x by 2, that is 2 sine square x. And 1 plus cos 2x is 2 cos square x. 2 gets cancelled, you will get tan square x. So finally this sec 2x minus 1 by sec 2x plus 1 has become tan square x. X was already there, so let's write this as integration of x tan square x dx. So how to do this? Exactly in a similar way, we have done integration of x into tan square x. So the same question can be presented in a different way. So you will start with there and comes up to x tan square x, and finally you see the solution which we have already discussed and I have explained it already, so you may revisit it. This question, if you watch very closely, there are separate terms here. X plus 1 into e raise x. Inside log you have x into e raise x. Now in the differentiation we have already learned and seen and solved x into e raise x. If you differentiate it, you are going to get the first term. I'll show you how it will unfold. If you take t equals to x into e raise x, this dt by dx will be equal to what? You know how to differentiate this. Take x, e raise x will be e raise x, plus now e raise x, differentiation of x will be 1. You can take e raise x common, you will get x plus 1 inside. And then dx can be taken on the right, so dt will be equal to e raise x, x plus 1 into dx. This particular thing or this particular relationship can be used because we already have x plus 1 into e raise x in this question. So this e raise x, x plus 1 into dx will become dt. X e raise x you have taken as t. So after this replacement or assumption, this integration will become like this. Log is already there, x e raise x we have taken as t, and then x plus 1 into e raise x along with a dx. All these two terms which I am pointing out, they are simply dt. So just write dt here, and there is a space I left because ultimately you have to integrate this. And how to integrate log t? Integration of log t can happen if you have a assumption that 1 is multiplied by log t, and you assume that one is a first function, other is the second function, and it totally depends on the integrability of the function whether it has to be taken as the second function. So we'll take log t as the first function and 1 as the second function. When we apply the formula, log will be coming first, log t, integration of this 1 which is 1 dot dt minus integration of differentiation of this log t will be done. And log t differentiation is simply 1 by t, you already know that. And then the integration of 1 dot dt, and once this is done, all the result will be integrated again with respect to dt. So we have log t here. Integration of 1 dot dt will only be t minus integration of 1 dot dt will be t. D by dt, that is differentiation of log t will be 1 by t. 1 by t cancels with t. Only 1 will remain, so you are actually integrating dt here. 1 dot dt is integration of dt which will be t plus constant of integration. Now we have already assumed something, x into e raise x. So the replacement has to be done. Wherever you find t, replace it with x into e raise x. You can also do one more thing in order to simplify it. You can take t common. When you take t common, log t minus 1 plus constant of integration can be seen. Now replacement, t is x raise e raise x. This is log, in the place of t, write x into e raise x minus 1. Let me change the bracket in order to show you the clear separation between these two. And then of course with a constant of integration. That is your final answer. Now this is the result, and these are the step-by-step explanation which I have already gave it to you. And you must follow this, because if you understand x into e raise x differentiation is x plus 1 into e raise x, this question is easy. Now this sine inverse 3x minus 4x cube, and one more question is coming up which have the same kind of say ambience, because sine 3 theta and cos 3 theta, especially in the context of inverse trigonometric function, if we are aware of that, this question will be quite easy. So the formula has to be learned. They have to be learned by heart so that these type of question can be approached. If you take x equals to sine theta here, now this x equals to sine theta, if you differentiate this, dx by d theta will be cos theta. That means dx is equal to cos theta d theta. But x was taken as sine theta. So from here theta can be computed, so theta will be sine inverse x. Now this integration will give you sine inverse. Now inside this, because x was taken as sine theta, I am replacing it now. 3 sine theta minus 4 into x cube will be sine cube theta. And then we have a dx also. So since we have converted everything to theta, dx also has to be written as cos theta d theta. From here to here, you already know the formula which I intimated you earlier. It's just sine 3 theta. So sine inverse into sine 3 theta is just 3 theta. Let me write it in a formal way. Sine inverse sine 3 theta, and the remaining is cos theta d theta. The sine and sine inverse can be cancelled. Only 3 theta cos theta d theta will remain. Because 3 is a constant, I will take it outside the integration sign. Theta cos theta d theta is to be integrated. Now this is the start of the question, because previous one were only the simplification in order to integrate it. So just assume that we are integrating x cos x dx. Just as imagine that. There is only a change. X was taken as theta. There is nothing else being changed. So we'll take x as the first function, cos x as the second function. So theta as the first function and cos theta as the second function. This 3 is a constant. I will keep it in temporary storage. I will recall it whenever it is required. So first theta, integration of cos theta d theta minus integration or differentiation of theta first, then the integration of cos theta d theta, and the final of these two will be integrated again with respect to d theta. What is the integration of cos theta? It's sine theta. So theta sine theta minus integration of what is d by d theta of theta is 1. Cos theta we have just done sine theta, so you are integrating sine theta d theta again. So I am doing it here right now. Theta sine theta has already been done. We'll just replace this theta at a proper time. But we need to deal with this integration of sine theta d theta. Sine theta is minus cos theta. So this will become positive cos plus cos theta plus c. Now theta is sine inverse x. Wherever you want to replace it, you need to replace it. We have sine inverse x in place of theta. Sine theta was taken as x. Let me write x here. Plus cos theta. Now cos x was taken as sine theta, so you have to convert this cos theta in such a way so that you get that x and sine theta. Sine square plus cos square is 1, you already know that. Cos square is equal to 1 minus sine square. Cos can be written as under root 1 minus sine square. And sine square is what? It's x. So it's x square. Cos theta can be written as under root 1 minus x square. So let me replace this cos theta by under root 1 minus x square and plus constant of integration. And this all is along with a 3 because 3 was also there a constant. So when you multiply it by 3, this is the final result. Okay, so this is the way you are going to solve it. I tried to explain in very detail, and this is the short way you can do it. Now in this question also, the trigonometric identities and relationships, especially in terms of inverse trigonometric functions, are of very pivotal role. Sin 2 theta can be written as 2 tan theta divided by 1 plus tan square theta, as cos 2 theta can be written as 1 minus tan square theta by 1 plus tan square theta. So there are two separate formula which I just mentioned, and this sin 2 theta, this is what we are going to use it in order to make it simpler. If you take x equals to tan theta with reference to what I just intimated you, x equals to tan theta, it will become this integration will become sin inverse 2 tan theta divided by 1 plus tan square theta. Remember, we have just assumed x as tan theta. So it will be sin inverse. Now this can be directly written as sin 2 theta. Sin and sin inverse can be cancelled. You will get 2 theta. But what is theta? From here, since x equals to tan theta, theta can be written as tan inverse x. We'll see whether we require it or not. But still, we need to show the examiner that x equals to tan theta, theta equals to tan inverse x, dx by d theta will be what? Tan sec square x. So dx can be written as sec square theta d theta. So the integration has to be done for this 2 theta. There is dx also. What to do with this dx? Dx can be replaced by sec square theta d theta. So I am writing in place of dx sec square theta d theta. Now integration will be done. Now 2 is a constant, we'll take it outside the integration sign, we'll keep it somewhere and we will recall it at the proper time. Theta sec square theta, this question has already been done because we are at the 36th question. So the previous questions we already done, but for the sake of completion, I'll do it now here also. So this integration will be something like this: theta sec square theta d theta. Now first thing is which will be the first function, which will be the second function. Theta will be the first function we'll take and sec square theta remains the second function. So we'll applying the formula theta first, then sec square theta integration minus integration of d by d theta of theta. Again the integration of sec square theta. It's not 2 theta, I'll just change it. It's just theta. And then the d theta. Sec square theta integration will be tan theta directly. So let me first change this 2 theta to theta because it's actually sec square theta we are dealing with. Now let's continue. Theta tan theta minus integration of d by d theta will be 1. Integration of sec square theta is tan theta. So integration of tan theta has to be performed. And we already know the result. Integration of tan theta d theta has a direct result. So the first term is theta tan theta without any change. Integration of tan theta will be log modulus of sec theta plus constant of integration. Now the replacement has to be done because theta is being introduced by ourselves. We have introduced it. So it's our duty to replace it for the final answer. Now theta is tan inverse x. In place of theta, write tan inverse x. Tan theta was taken as x, so write x here, x tan inverse x, minus log, now sec theta. Because x was taken as tan theta, you have to have a relationship, and we have a relationship between sec and tan. What is the relationship? Sec square theta is equal to 1 plus tan square theta. So sec will be given as 1 plus tan square theta under root. So in place of sec theta, we'll write under root 1 plus tan square theta. And since tan theta was taken as x, so it will be simply under root 1 plus x square. So 1 plus x square I am writing here, modulus and then a constant of integration. But still we have one more thing, which is the 2. The 2 was taken as temporary storage. So now I'm multiplying everything by 2. 2 into constant of integration will be again a constant of integration. So 2x tan inverse x, you can simplify it also, minus 2 log under root 1 plus x square. So I am showing it to you here. Negative 2 is there, so 2 I am writing, log is there. Now this under root 1 plus x square is simply 1 plus x square to the power half. This half will come in front because log a to the power b comes in front, is b log a. Now then when half comes, 2 gets cancelled. So you are left with minus log in the modulus 1 plus x square. So 2 gets cancelled actually, plus constant of integration. And this is your final result. That's your final answer. Now how we are going to go about it? I explained you how to approach this and how to get the solution. So now again the trigonometric identities and trigonometric relationships will be employed here. As a straightforward solution, if you remember your earlier classes, tan inverse 3x minus x cube divided by 1 minus 3x square is simply 3 tan inverse x. It's a relationship. This what we have received to integrate is simply 3 tan inverse x. So we are integrating 3 tan inverse x. This 3 can be taken outside the integration sign, and then we can just integrate the tan inverse x. And tan inverse x cannot be integrated by itself, so you have to have a 1 multiplied by 1, and then we'll take 1 as one function, tan inverse x as the another function. If we take the tan inverse x as the second function, we will again be in trouble because we have to integrate that thing. So tan inverse x will be taken as the first function, integration of 1 dx, then d by dx of tan inverse x, and the integration of 1 dx. These both will be multiplied and the result will be integrated again in terms of or with respect to dx. Integration of 1 dx is simply x. So x tan inverse x, this is done. First term we have already got. This second term, d by dx of tan inverse x is 1 by 1 plus x square. Integration of 1 dx will be x only, and then we have a dx here. So x tan inverse x, let's write it here, x tan inverse x. This x by 1 plus x square will be integrated separately. I'm integrating it separately in order to just show you how it will be done. Then we'll write the answer here. Let's take t equals to 1 plus x square. When we take t equals to 1 plus x square, dt by dx will be equal to 2x. X dx, so this x will go up. So dt by 2 will be equal to x dx actually. So the numerator we can write it as dt by 2. So I'm doing it here. X dx, we are writing dt by 2, so half comes in front. 1 plus x square was taken as t. It's just log t. Log modulus of t with half in front. And t will have to be placed as 1 plus x square. So final result which we got is half log modulus inside modulus t, which is 1 plus x square. So I'm writing it here now. Half log modulus of 1 plus x square. Now the constant of integration from every term can be combined in one constant of integration. But there is a 3 also. Initially I told you. So just multiply 3 here everywhere. 3 into constant of integration will be constant of integration. That's your final answer. This is how this question will be done. This question is good, but until you know that 3 tan inverse x is actually tan inverse 3x minus x cubed by 1 minus x square. If it is known to you, this question will be pretty easy to solve. X square sine inverse x dx. If you can find out first function and second function, this question again will be easy, because if you take sine inverse x as the second function, we will get stuck. So first function will be sine inverse x and the second function will be x square. So this sine inverse x will be the first function. Then the integration of what? X square minus integration of differentiation of sine inverse x, d by dx of sine inverse x will be done. Then the integration of x square will be done. And then the result will be integrated again with respect to dx. So sine inverse x it is, x square integration is x cubed by 3. So x cubed by 3 is sine inverse x minus integration d by dx of sine inverse x is what? 1 by under root 1 minus x square. This x square already done, x cubed by 3 you can write, and this has to be integrated again. So the first term has already been received. We have a 3 in both the terms. So we are integrating x cube divided by under root 1 minus x square. 1 minus x square can be taken as t. dt by dx will give you negative 2x. That means negative dt by 2 will be x dx. Because we need x cube or x cube as x square into x. You can write this x cube as x square into x, then with a dx. So this x dx has become negative dt by 2. So minus, you can take it outside, half minus dt by 2, dt here, negative half outside. X square can be taken from here. X square will be 1 minus t. So let me write 1 minus t here for this one. And then we have under root 1 minus x square, which is essentially under root t only. So minus half is there and 1 minus t by under root t is there. Minus half we can deal later. Let us put it in some temporary storage and deal with 1 minus t by under root t. Let's separate them out. 1 by under root t as a separate term with a dt, minus t by under root t as a separate term with a dt. So 1 by under root t is what? T to the power minus half, it goes up. And when we integrate, it will be simply x to the power n integration. So when you integrate it, it will be t raised minus half plus 1 divided by negative half plus 1. This will be t raised half by half. This 2 will go up. It will be twice under root t. You already know that. I'm writing it here, 2 under root t of the first term. Then dealing with t by under root t again. The best way is to multiply numerator denominator by root t. Alright. So you will get a root t and you know what is the integration of root t. Or you can do like this, t raised 1, t raised half in the denominator, t raised half goes up, 1 minus half is half, t raised half which is under root t, it will be t raised half plus 1 divided by half plus 1. So t raised 3 by 2 divided by 3 by 2, it goes up, it will be 2 by 3. So 2 by 3, t raised 3 by 2. Now we have a negative half here. Let's multiply this negative half with the negative 1 by 3 because ultimately we are dealing with the integration of x cube by under root 1 minus x square. So minus half and minus 1 by 3, just assume that I have already multiplied it. Minus minus will become plus. It will be 1 by 6 actually. And this 1 by 6 will be multiplied here. So I'm multiplying it here also, 1 by 6. So this will be 1 by 3. So root t by 3 here. This will be 2 3s are 6, so 9. So minus t raised 3 by 2 divided by 9. So ultimately we got root t by 3 minus t raised 3 by 2 by 9. Now the time of replacement has come. We have already dealt with 1 by 3. We have dealt with negative half. So this needs to be replaced here. So x cube by 3 sine inverse x remains unchanged. We haven't changed it as of now. It needs not to be changed also. So what is t? Because t was a 1 minus x square. So you can write this under root 1 minus x square by 3 minus 1 by 9. T raised 3 by 2 will be what? So t is 1 minus x square. So 1 minus x square to the power 3 by 2. Keep it like this. Don't worry about any simplification here. So 1 minus x square to the power 3 by 2. So these two terms are to be appended after this term and that will be your final result. So let me write it under root 1 minus x square by 3 minus 1 minus x square divided by 9, and this 1 minus x square has a power 3 by 2 plus constant of integration. It's your final result. Okay. So the question we have just completed, this is the formal reference of this question which you may follow whenever you are trying to do it by yourself. Now this will be taken later. Thank you so much. Have a good one.